Good morning, everybody. Today I'm just going to go over some Hotend basics. This is one of the Hotends out of an Ender 3, also found in a 5, 5 Plus. A bunch of printers have this particular Hotend style. There's a couple different styles of Hotends, but they're all basically the same. And I'm just going to use this as my model today. So we're just going to talk real quick first about the parts of a Hotend, and I'm going to talk about setting one up and making sure the nozzle and the heat break are set correctly so you don't get clogs inside of these. So we'll start from the top here. This is your Bowden Tube. This feeds the filament down into the Hotend itself. Compression fitting. This holds this tube in place. To release it, you just compress this ring and slide it right out. So we'll get that out of the way. By the way, this is a brand new Hotend, so everything's going to come apart super easy for me. Chances are, if you're working on one that's been used, you're going to have to heat things up to get it apart. They tend to stick pretty good. So let's go grab a wrench real quick. Alright, so they're going to take this compression fitting off. And all this does is holds the Bowden tube in place. Alright, inside of there you can see it goes right down through to the top of the heat break. The heat break is hollow all the way down to the top of the nozzle, and then the nozzle is where the plastic is actually melted. The heat break keeps the heat at the nozzle and away from this area here, so during retractions it doesn't melt your plastic and causes it to stick, jam, and otherwise cause problems. Alright, so this is the heat sink. Inside of that is the tube, which is the heat break. This copper piece right here is the heat block, and this is your silicone boot. So this just peels off. This is the thermistor wire, the white one right here. And this one here is your heater element wire. Typically these are held in by a small Allen head screw. This screw does not get tightened down hard. It's just to hold the wires in place for the thermistor. I'm going to remove the electronics from this just to show you the next step about setting up these. And it's just a lot easier to do it with this out of the way. So this grub screw here holds in your heating element, and this screw here holds in your thermistor wiring. This does not get tightened down. This can get snugged up pretty good. It's just a metal body in there. Just kind of push that out and slide that out of the way. That's your heating element, and we're going to just undo the thermistor wires from the screw. And at the end here is a glass ball. This is the part that goes inside of the heat break, or heat block rather, inside that hole, just like that, and then it goes around the screws. That little ball is what actually senses the temperature of this device. So we'll move the electronics out of the way. So now we have just this unit. So what I'm going to talk about, I have a model to show you. When these are set up at the factory, this one happens to look correct. There's a gap there between the top of this nozzle and this block. When they're set up at the factory, it's sometimes possible for these to be too tight up against the heat throat or the heat break inside, and it can leave a gap. So I'm going to go ahead and crack these all loose, and I'm going to take it all apart completely, and then I'll show you the model. And then we'll put it back together, and you'll be able to see and understand what I'm doing as I'm reassembling this. So, just hold on one second while I just take these all out. Okay. Always make sure these screws are tight, because these can loosen up and cause problems with the Hotend wobbling. There's a set screw right here that holds this together. And I'm going to go ahead and take that out too. So here it is, completely stripped down, except for that screw and that grub screw. So this is your heat block. Again, this is where your heating element goes and your thermistor go. This is where the heat break, which is this piece, screws in. Alright, it goes through there, and in the middle, it meets the top of the nozzle, like this. So the problem with this is when I see a lot of printers coming, especially from the auction, is this is all the way down, tightened all the way down against that heat block, flush. Alright, so let me get the model over here. This is a crude model, so don't pick on it. I know it didn't print great, but it's going to serve its purpose. So this is a cutaway of basically this. Alright, pretend this is gold. I didn't print it in gold. Okay, so this is a cutaway of this. I'm going to slide this off the top of it. We don't need that right now. Alright, and as you can see here, if I tighten this all the way up, right against the bottom of this, there is no gap here. But you can see a gap here in between. The reality of it is a lot of times you can't tighten this all the way down. It runs out of thread and it won't seal this gap. So what I do, oh, I'm sorry, I meant that the other way around. You can tighten it down. This you can't tighten all the way in because you run out of threads. So what I do is I back this off about a thread. And with this all apart like it is right now, I turn this down some until it meets up with the nozzle. You'll feel it get tight up against the nozzle, and then you can double check the nozzle is tight up against the heat break. So you've sealed the gap between these two. Now there's no place for the plastic to get out and start to form a blockage, which is a common what's known as a throat block. It'll form a gap right here. It'll fill this gap in. And what tends to happen is this will get cool and solidify and start to make a donut. The filament will go through for a while. You'll start to see under extrusion first, until just like a clogged artery that'll fill in, and then your plastic can't get through anymore. It solidifies completely, your extruder starts clicking, and you're no longer printing because you're completely blocked up. The block is usually right here. Now to fix that, all you have to do is heat everything up on your machine, and very carefully, don't burn your hands. Take your nozzle out. Take your compression fitting off the top of your heatsink, dropping stuff, off the top of your heatsink. So it'll actually be still together like this. Alright, and you'll have this nozzle off. Tighten it down. And what you can do is you can start with a piece of scrap Bowden tube and push through. It'll push the clog out. And then what I use is a Q-tip. It's kind of hard to get a Q-tip through there, but if you roll the tip of it first and push it through, it'll go. And that'll squeegee the walls down clean. And then just reassemble everything. Like I said, it's best to do this when everything is hot, because once this has been run through with plastic, it's very typical for these to not be able to be turned anymore, because they kind of like bond together like glue. But if it's hot, you might be able to break this loose. And what I'll usually do is I'll usually run it all the way through a bunch of times to kind of clean the threads up, get all the plastic out of there. I'll take it apart, I'll put Q-tips in there. I use a heat gun to heat the parts up individually if I have to. And there's a whole process to cleaning these. Maybe I'll do a video on taking apart one that's like basically destroyed and recovering it, because it is possible to recover these. Nozzles I don't recover, I just toss those and get new ones. They're so cheap. Alright, so anyway. So what I'm going to do now is I'm going to basically put this together the correct way, so that I'm going to start with my nozzle about there with the gap. Now you see there's a gap here. This is the gap I'm talking about. I have a picture I send out a lot of times that shows this, but I figure a video is probably a better way to explain it. You'll see the gap here, and then I'm going to tighten down my heat brake and my nozzle. So I still have a gap, but I'm tightening the nozzle last against this. If I do it the other way, there's a good chance that they won't meet in the middle. Usually it'll stop like about there, and I'll have that gap. So anyway, I know it's kind of confusing, but so what I'm going to do is I'm going to actually back my heat brake out. I'm going to set my nozzle first so you guys can see it. And I usually just leave it about there, about that much, about a thread or so. So I have some room to tighten. I want to tighten at least 2 turns after the fact, but I don't want it to bottom out either. Now I'll install this. And if you ever have this completely apart and get confused which way this goes, these have these filleted holes. That's for the screws heads. So this is the bottom, this is the top where this goes. Alright, you can see there it is, the top of the nozzle waiting for me. I'm going to go ahead and tighten this in down to where it stops, right up there. And now I'm going to go ahead and tighten this up Now this is not tight because you have to wait till it's all installed in the machine and everything's hot to tighten it completely, but you'll notice that even tightened up against the heat break, still a gap. Be careful when you put this back together again. You're going to have to reset your Z offset if you are adjusting this in your printer because you noticed it was bottomed out. So make sure you watch out for your build plate. Don't scratch up your build plate. If you have glass, I recommend flipping it over. If you have something other than glass, just be super careful when you start printing. Be ready to stop that printer because you might have to change your Z offset pretty drastically because you're lowering it quite a bit. If you have a probe, it'll help. If you don't have a probe, you should be able to set it with the Z offset limit switch. You might have to adjust your switch height. If you have any questions about setting up, if you're doing this to an existing printer and you need help changing stuff over, just let me know. Alright, so that's that part assembled. I'm going to go ahead and put the rest of it together just so you can see it on camera. This grub screw faces the larger portion of this, so it's facing out towards me with this on the right side. So we're going to go ahead and just snug that down. Not going to tighten it because we want to be able to move it to put the screws in. I just want to keep it from flopping around and falling off. Alright, so screws go in. 1 and 2. And I usually will just get them very gently started. Don't cross thread anything. Just a little bit just to get it started so everything lines up. Once it's lined up, I'll bring it down to its seat. Again, not tightening yet. I want to get them even. So I'll bring it right down. Same thing with this one. A lot of times I use power tools for this, but I'm doing it with hand tools just so I can show you everything I'm doing. Okay, get that all the way down. And now that they're pretty much on and even, I'm going to go ahead and loosen this up and start tightening. Just a little bit of time on each side until I feel like they're completely tight. Again, you want to check these periodically. I've had these loosen up and they can cause your hot end to wobble and get all weird. Messy layer lines and stuff like that. But check these bolts. You also want to check these guys when it's in the printer. Alright, so that's tightened down. I'm going to go ahead and tighten the grub screw back up so it's holding on. And then we're going to pretend that this is my machine and I've got it all hot again. My electronics are all installed. I'll do that real quick just so you can see that. I know that's this is tricky right here. This screw, terrible design. Alright, so I'm going to slide this in first just to get it in there. And we'll put the glass bead on as well in the hole. Okay, and I'm going to pull the wires under that screw. This is where it gets kind of finicky, getting these wires to cooperate without damaging them because they're so little and so easy to damage. You have to be careful. So what I usually will do is I'll just kind of like get them lined up like that as best I can. And I try to hold on to the top of it, not cutting it with my fingernails because it's really thin wire. Just want to hold it like that because all I need is that ball to be in this hole, these wires to kind of be under the screw. They don't have to be perfect, just there. And I'm barely going to tighten this, and I mean barely. Lightest pressure on those wires. If you go too hard, you'll ground them out against this, short it out, and you'll get no reading on your thermistor, and that'll be why. So now that that's in, I'm going to go ahead and tighten the grub screw down on the heating element. Okay, it makes it tough because these are taped together with Kapton tape to keep the heat off of it. So it makes it tough to maneuver these separately. You can get this tape off of Amazon. If you have to pull that off, you can always put a new piece on. But it just kind of keeps it nice and neat for your machine. Alright, just to finish the installation, I'm going to go ahead and install compression fitting. Just so you've seen everything. And the Bowden tube. When this Bowden tube is in here, first of all, make sure this is flush cut. It has to be perfectly straight, flush. When this is in here, this needs to be at the top of the nozzle, which is approximately right there. It'll be that deep inside, so that much of that tube is going to go in there. And if you look carefully, the teeth of this are kind of like right at the top of this nut section of this, right about there. If you look carefully, you'll notice there's a mark on my tube from being in there where the teeth bit it. And you'll notice the depth of that. It's right at the nozzle. So that was in there perfectly. That's a good way to know that you're going in that far. Alright. There's no exact measurement from here to here because this is variable. But it's about this much. So let's just say it's about... Grab a ruler real quick. Depth is about 43. 40, I'd say between 40 and 43 is probably correct. So you should see a little bit of a band mark right here where the teeth have bitten this tube if you take it back out. And that'll indicate that it's going down deep enough. Like I said, it should be about that high because that nozzle goes in about halfway up the block. So we're going to go ahead and set this. Push it all the way in until it stops. And you'll know it's in. You won't be able to go any further and you won't be able to pull back because these teeth have bitten into it. So what that basically just did was that brought that tube right down against the top of that nozzle. It's sitting at this flat spot in this nozzle right here. So there's no place for the plastic to go except into the nozzle. That's the whole point of this. Alright, so there you go. That's set back up. So I would put this back in my machine. I would heat everything up to operating temperature. Grab my wrench and once again snug this down while it's really, really hot. Just to make sure it's super tight. And off you go. Happy 3D printing. If you guys have any questions on everything I covered here today, let me know. I can certainly answer any questions you have. If you have any other model hot end you want me to see me work on, if I have one, I'll show it to you. If not, I can at least explain what you got to do with it. But other than that, that's about it. Thanks, guys.